We're going to be looking at the linear parent function on this video. So the name of this parent function is linear. The equation of the linear parent function is f of x is equal to x. F of x, as we know, is the same as y, so really this says that the y is equal to the x for all x's. So if I pick a few x's, just to fill in here, since x is your independent variable, we can pick any x's we want to. So I'm just going to pick a few, like -1, 0, 1, and 2. If I put this -1 back into this equation in place of the x, then it would say that the y value is equal to -1. So when x is -1, your y is also -1. If x is 0, then this would say that the y is also 0. If x is 1, the equation would then say that y is equal to 1. And if x is 2, then the y would be 2. If I want to see what this graph looks like, I can then take these points, -1, -1, 0, 0, 1, 1, and 2, 2, and plot them. So I'd start at the origin here. -1, -1 tells me to go to the left 1 and then down 1 and put a point. 0, 0, of course, is over none and up none. 1, 1 is over 1 and up 1. 2, 2, over 2, up 2. And this is really enough for me to get a sense of what this one looks like. It appears that these points are falling along a line here. And so I could just connect the dots here. The pattern would continue. If you're not sure, of course, you could always pick a few more x values. But the pattern continues forever in this direction, and it would also continue forever in this direction. And I'm putting arrows on the end to indicate that it does go on forever. That way I don't have to continue drawing the line forever. Now for the domain is the set of all x's that we're allowed to put into this equation. So really, I could take any x value I want to and put it into this equation, and it would give me a y value to go along with it. So I would say that the x values are any real number. And the way we indicate that is we say x belongs to the set of reals. Now, since the y's are equivalent to the x's, then that means if x can be any real number, then that means y can also be any real number for the range. So I would write that the same way. So y belongs to the set of reals. Other important things to know about these functions are intervals where it is increasing and decreasing and constant. Now when we list these, we're going to be listing the intervals of the x values for which this is increasing or decreasing or constant. Now increasing means as I move from left to right on the graph, so as I move this direction, where's the graph going upward? So where are the y values getting larger? Now if I look at this on this graph, it's always going upward. So that means this function is actually increasing for the entire set of real numbers. So we write that in interval notation as we say it's from -infinity to +infinity. And we enclose it with parentheses. Now if it's increasing from -infinity to +infinity, then that means it can't ever be decreasing. It's always increasing. So we'd say none here. Decreasing would mean that it's going downward. And then for constant, in order to be constant, that means as you move from left to right on the graph, the y's have to be staying the same, which would produce a horizontal line. Now nowhere on this one is there a horizontal line, so we'd also say that it's not constant anywhere. Always increasing would mean that it's never decreasing and never constant. The things you need to know about this function are the name of the parent function, the equation of the parent function, the graph of the parent function, the domain, and the range. If you know the graph, then you can find intervals of increasing, decreasing, and constant.